Dang. What? New faces?
Huh?
New faces?
No, not new face. We are always here.
Always. No.
When you look at the attendance sheet, you'll see.
I'll see.
Yeah. It's just last class that I did not do.
Yeah.
Oh, goodness.
Actually, it's not a problem.
I think I saw you in the morning. And then you just started saying, reinforce something, you're in reinforce. Yeah. Oh, goodness.
One viewer online. Any chance somebody coming?
Of course.
Man. Okay. Nothing to wait. What I got for today? one of the most used thing from all this course. It's an application of DFT for network calculus. Very usable thing. I don't know how well it's going with circuits theory or electrotechnics basics. How it's going with electrotechnics basics? Have you completed?
Sorry?
Electrotechnic basics course?
No.
No?
No.
And what are you doing here in this case if you don't have a basic electrotechnic course?
Because as electrotechnic.
Yeah, basics of electrotechnics.
No.
Any electrotechnics course? Zero.
Electronics? Yeah. I
No.
did basics of electronics.
Basics of electronics.
Yeah, but no.
Okay, electronics. And what kind of currents you deal in course of electronics? You got DC,
DC,
yeah?
yeah.
And nice ideal AC current, yeah?
Yes, yeah.
And what if you have something else?
Something like that.
Some general current. Something like current.
We use the Fourier transform.
Yeah. We use the Fourier transform. Here, I took as an example, very popular thing, rectifier. Yeah, simple network with rectifier. If you take any inverter, or something like this, what you will find at input stage? Rectifier. Nice example. So, how can I solve, for example, a rectifier network? By the way, this one is three phase. I can disconnect, for example. Here is output voltage from standard bridge. And this one is three phase. Okay. Let's say
Three pieces.
I have something 1, 2, 3, 1, 2, 3 within one period of our network frequency. If we have a 50 Hertz, what will be period? Oh, 20 milliseconds. How can I solve a linear? Here is one moment. Network should be linear. Voltage should be proportional to current. Ohm law should be enforced. This will not be a DC network. No, because this is not DC. No, it's close, but it's not.
Okay.
It is not AC network. We need to do something. So, idea. I can assume what this one is my signal. And I need to obey a limitation. If this should be a periodic signal. Next, with the help of DFT, I can transform it to C0, C1, S1, I don't know, CM, SN. What are these components? This one is ideal DC. This one is ideal AC with the frequency 1 omega. Next will be 2 omegas, 3 omegas, and so on up to m omegas. I got a set of one DC component and multiple AC component. I got it with the help of Fourier transform. Next step. Look who's away. Next step, when with the help of discrete time Fourier transform, I got this ideal components of harmonic, I can take my network, the capacitors, resistors, coils, and couplet coils. What about couplet coils? Huh? Capacitors, resistors, coils, couplet coils. My network may contain all of this, all these basic elements. So I need to apply my DC source and my multiple AC source to this network. What I will get? Network regime or mode, or I will get voltages and current. This Z means ZARS. It's from Latin. It's a branch current. So I will get a set of nodal voltages and branch currents. This set, by its nature, called set of partial regimes, is a set of Fourier coefficients. My next step is to perform an inverse Fourier transform on this set. This will get me real voltages as a time function, real branch current as a time function. So technique is, at basic, decompose, perform and calculus on partial regimes, on partial modes as you want, perform and synthesis. And one more, let's say prologue on, it's called. One more preliminary step. At this preliminary step, I don't want to perform Fourier transform by hand. I would like to, let's say, delegate this to machine. So I need to do or to organize this process numerically. And to do it numerically, I will need a table of signal values for one period at last. This trick, as I do, is for periodic signals. But in most cases, it's okay. So one of the first step here between signal and DFT, I need to perform one more preliminary task. And this task is creation of signal table. I need from continuous signal, this signal is continuous, convert to the set of values. I will feed the set to, where I will feed the set? I will feed the set to discrete time Fourier transform. So here first step, I have rectified. Power from three-phase network. This is ground. Here I have three phase on primary side. On a secondary side, start connection. And this will be A phase, B phase, and here, for example, C phase. I assume this it's easier for me to take a negative pole as a reference point. It's not mandatory, but it's just easier for me to attach scope. If here I have free phase 50 Hertz, this is my signal to apply my knowledge from signals theory. So I have a voltmeter. 10 volts. Here, my nice three-phase transformer. I spent 20 euros on it. It's my transformer.
You purchased it?
I bought it on the free market. I don't know what the purpose was originally, but I can assume that it's from some old data processing equipment. But I bought it from guy, he got a close school on sale. Oh, class remind my university day. Welcome, welcome. What I'm trying to do, one moment. I need to do something. Oh yeah, okay, yeah. This one need it. I will work with this. I will work with this. I will switch to what? Not everything working fine. One moment. I need to fix this. Oh, okay. Not okay. I'm seeing this one. Okay, it's integrated. Oh. One second. What is this? Ah. And you will go up. Yeah. I'm started with something. One moment. I will turn my camera and what? And I will attach a cable. Attach this cable. Oh, I have a nice white space to write. Okay, I got a measurement. This voltmeter shows me exactly 10 volts. Who can tell me mass description for the signal, for the yellow line we just saw?
Sorry? The description?
Yeah, mass description. What will be formal for yellow voltage? Here, you can look at yellow voltage. Can you tell me formula for yellow voltage if this voltmeter shows exactly 10 volts? I think I can believe it. Can I trust you? Hey, voltmeter. Mass formula. It's so easy.
Okay.
It's easy.
Mass formula.
What we got here? Three-phase bridge, yeah? This bridge will yield us at output water voltage largest of, we have three voltage, AB, BC and AC. It will give us at output large of this voltage. Yeah? Who know what is three-phase bridge here? First time see? Three-phase rectifier.
I think one done single phase.
Got one phase. If, for example, scope, please. No, not this. Wire, where are you? Oh, this wire. For example, I'll disconnect phase C. I have disconnected phase C. Do you see voltage? What's the mass for this voltage? I have disconnected this wire. What's the mass expression for this voltage? Voltage at this point. Forget about this branch. These are familiar. You completed electronics course. Don't look at me as I'm doing some blasphemy. You completed electronic course. What will be output voltage of bridge? Here, at this point. What we will see? Here, voltage will be simple. At first, something like this, yeah? And what we will see here? If voltage goes up, opens this and this diode, yeah? If voltage goes down, at this point, who works?
Those two.
This and this. As a result, this will be result. Yellow line looks like expectable result. Huh? You completed electronics course.
So what's the reason why you still have some voltage in the negative? It's the negative amplitude, those small values.
Actually, it's not negative. We need to. 1 second, I will switch off and we will see where is. Here is 0 line. 1 second. I need to go here. I need to go here. I need to push here, and I need to select DC here. And I need to do. Ah, 1 second scale. This one is better.
Yeah.
Okay. What's the mass expression for this? Sine or at the transformer output it will be sine, and this one, no? Absolute value of sine. Voltage what we see is absolute value of sine omega t. But what in front of it? I have 10 volts here. 10 volts is a phase voltage, yeah? You know what we got? A three-phase network here. A phase, B phase, C phase, ground wire, neutral, and PE means protective earth. They are connected. If, for example, here it's written 3 multiplied by 220 volts. If I measure like this, I will see 220. If I measure against ground, what we will get? If face to face is 220, face to ground, what will be? Square root of 3. Here, I have phase voltage measured as a 10 volts. But what voltage is applied to the bridge? Line to line. So, I'll need to have square root of 3. Yeah? Next moment, I left space it. For what I left space? 10 volts is an effective value or amplitude. Effective. My voltmeter pretends to be an RMS. These 10 volts are RMS. But I need a mass description. For pure sine, factor between RMS and magnitude is square root of 2. That means what I need a square root of 2 and 10. So, equals 10 square roots of 2 square roots of 3 absolute value of sine omega t. This is for now yellow line, it's a simple bridge. If I attach the third phase, mass description will be here, for example, I can write equals 10 multiplied by square root of 2 multiplied by square root of 3 multiplied by more space multiplied by maximum of sine omega t. Sine of omega minus 2/3 sine of omega t plus 2/3. Three-phase network. Where is my C phase? Oops. Here is my voltage. My nice output voltage in case I have three-phase bridge. 1, 2, 3, 4, 5, 6 diodes. Full bridge. On the input of good inverter you will see three-phase input, 6 diodes. So I need to create a signal table. One moment, I will check. No, don't need this. I don't need this. This one will help me. Yeah. It's another form of electrocution. Don't worry, you're not gonna die instantly. Oh. Here I should have 10 volts. Do you see my nice program?
What is N representing? Capital N?
Okay, let's go. Frequency 50 Hertz. Maybe. Can you translate? What's your knowledge in Latvian? What's in signal table?
Table of signals.
Yeah, it's a table of signal. I will need, okay, 720 points is okay. Here, take a look. AM is a max value of my voltage. Square root of 2, square root of 3, my 10 volts, I just put it. But here is small. Any ideas what this 06? Why? Huh? Guys who studied electronics. What about this 06? It's a voltage drop on diode. Next, what this one? Tau is a step of the table. Values will go visible. What will I do? Time, my signal. I will take samples. Sample 1, sample 2, sample 3, blah, blah, blah. The next one will be sample number 720 or n, this one, and minus 1. Tau is a step between samples. Here it is. It's a step. And here, take a look. Fourth cycle. Count 1, 2, 3 up to number of points. 720 is with a step of half degree. I don't know, I just like this number. I can take big, smaller step, but it's not very important at this moment. Here, Vt is an array of omega time values. I will just use them to draw a chart. And also, something familiar in a blue. The formula I just wrote on the table. Yeah, familiar formula. I need to draw a table of S maximum multiplied by maximum of absolute values of omega t, sine of omega 230 and sine of omega plus 230 when S maximum is my voltage multiplied by square of 2 to get max value as and square of 3, because I measured phase voltage, not line to line. What will be the result of this code? I should get with the plot nice chart of my signal. Yeah? Let's take a look what I will get. Oh. Maybe I can enlarge it. Yeah, here is chart of my signal. Can we, for example, if I uncomment this line and comment this line, this will be simple bridge rectifier. Oops. Oh yeah, they're in comparison. Look, I created a rectifier comparison. Three-phase bridge and simple bridge. Yeah. Here it is. Simple bridge. Something familiar? Yeah? Okay. This appears what this stage works. What next? I need to perform Fourier transform. I have a very good idea for Fourier transform. Where is my? I don't. Yeah. I don't like it. What's the idea? Basic mass for the Fourier transform, Ck can be calculated divided by time, from 0 to time. My signal, cosine of double P divided by period. Yeah, I'm writing correctly. The time. And sine factor can be found as double divided by P. Integrating from 0 to period, my signal, sine double P divided by the time. Who is going and why? One second, I will respond.
Using side of the ink.
Maybe write it in.
No, it's just inside now. So
Okay.
the syntax is different.
Yes. When I come to this class, I feel sleepy. Huh?
Yeah, it's just inside of the ink. Using
have Scilab.
So it's
Oh, you can do Arduino with Scilab.
yeah, again, yeah, yes. It doesn't work excellent lab as well.
We have a lot of labs.
Лекція нотик. Ми тайськуєш
Very
трансформер.
slow when it comes to typing.
What I need to do? I need to convert this to numerical form. I can use a very simple thing. I can substitute this integral with the sum of areas. So it will be 2 divided by number of points. Sum that I change from 1 to number of points in the table. Signal value from I tau. Cosine of 1 second is back I minus 1 double p divided by number of points. And sine factor will be sum r changed from 1 to number of points. Can you please stop? Sine of I minus 1 k double p divided by n. Here are two nice formulas for discrete time Fourier transform. Basic formulas for discrete time Fourier transform. And this is applicable, of course, if my signal is a periodic signal. Here m is integer. Okay. I will put this code here. Okay, fine, or not so fine. What kind of code I have here? Maybe you, if you are not interested, we have a lot of place to sleep. You sleeping. And it's dangerous, because when you fail, you will break your face. And I will be responsible for a broken nose. Don't look at me. By the way, I saw one guy fall asleep walking on a circular saw. And was this far from being decapitated by the 12 kilowatt circular saw with like this cutting blade. He just fell asleep while pushing ahead wooden. It wasn't wooden, it was composite like this. Guy just fell and was this far from dying. And making it nightmare for all of us. It's nothing fun to be stained in someone's brain. Okay, let's go forward. What I have here, number of harmonics. I need to limit somewhere the frequency range I will operate. So n harm, okay, will change from, at this point, from 1 to n harmonics. It's a range of AC components. Actually, it's a number of AC components. In my case, it will be 70. I don't know why. So, for each harmonics, I perform, you see, this fourth cycle from 1 to number of harmonics. And here I'm calculating some sums. Something familiar, isn't it? These two formulas I wrote on a table. Here they are represented for computer. I will not calculate this by hand. If you want, you can. I will not do it. Machine will work. Machine works, human relax. Familiar? The thing you see on the screen matches the one I wrote on the table. This one is dead now. If you want to sleep, go sleep. Okay, one tiny moment. I need DC component. The part I show in blue is a DC component, C0. It's simpler. I'm calculating C0. Just put 0 in the first equation, first formula, and you will get DC component. So, I got what? If this works fine, if I made no mistake, what I will get? One DC component and 70 ideal AC current. What's next? I need to check. How can I check my work? How can I check correctness of transform? Fourier, Jean-Baptiste Fourier, started from idea what any periodic signal can be substituted with DC component plus some from 1 to maybe infinity of cosine double P divided by plus sk sine of double P divided by time and divided by period and multiplied by time. This is basics of Fourier rule. What I can substitute any periodic signal with a set of harmonics. If I perform this formula on my table, what should I get? Original signal. They should match, yeah? If I did so, this set is correct. If not, I did something wrong. So, here is synthesis. Very simple synthesis by this formula. Here is C0 by half, and from 1 to number of harmonics, I perform this Fourier synthesis. Result, I make a trick. Resulting line should match my table. If not, I'm doing something wrong. Let's take a look. What will happen? Oh, 1 second. Not 0. Here it is. For my viewer. Look what a nice chart I have. if I magnify, green dots are values of table, and blue line is a result of synthesis. Good match, isn't it? Maybe I can perform better. How can I perform better? Maybe add more points. I can double. Hello. Oh, this one is fine. Nice? Nice. BTV, I would like to show you one thing. Where is number of harmony? This will work, no? Still works. Something goes wrong. Yeah, something goes wrong here. And yeah, we got. You see, nothing happens because Nyquist frequency. Okay, maybe. Real. Oh, let it be nice. Original. And what about this time? Oh, we can live with this, I hope. They are very similar. Now, next step. At this point, everything is fine. And now I need to go forward. And what's forward? I have a signal. Signal. Yeah. Now I need to calculate a network. I need to perform a topology analysis of my network. For one DC component and 70 AC component. What about topology analysis? Who is pro in network solving here? Okay, let's go. I need a way to solve a network. It's my. Now I need a way to solve a network. And what I will do is a nodal analysis. And it's not an easy. Not a very easy thing. What's the idea? First, I have AC source. Time, maybe maybe you find another way to sleep. Come on. What I want to do? First idea. It's idea of Oliver Heaviside. idea is what I can substitute this time function with a vector on a complex plane. Yes, difference. Oh, I can substitute this vector on a complex plane and perform an analysis with a complex values. In the complex world, resistor will remain, active resistance will be active resistance. Coil with ability to store magnetic energy. What I need to use? What will be voltage on coil?
No, the derivative of current.
Derivative of current. So, OL L by time. If current is sine, derivative will be cosine. Yeah? On a complex plane, sine cosine, it's just a rotation. So coil can be represented with the imaginary reactive resistance omega A. If you take a derivative from sine omega t, you will get cosine. Yeah? Cosine. Sine. Familiar thing. Unity circle. So, and if voltage is here, okay, voltage is here, where will be current? Current will be here, meaning 90-degree phase shift. This 90-degree phase shift can be represented if vector of current is a vector of voltage divided by J omega A. This will be fine. For capacitors, capacitor with capacitance C. This one, 5 microfarad. Will be what? 1 divided by capacity from 0 to time, t not time, or sum of all charges. With Heaviside idea, actually, Heaviside just bring an idea. Real output of this technique is a Charles Pratel Steinmetz. Anyway, capacitor can be substituted with its x being 1 divided by J omega C. If you take an integral of sine, you will get minus cosine. Means rotation by 90 degree. Which way? Forward. One more. Cosine, sine. Voltage is a sine omega t. If voltage is here, minus cosine will be here. You need to go forward. One more element. Capital M, not meaning more reactive, but meaning mutual inductance. What's the meaning of M? This large, white, yeah, mutual inductance. But what's the physical meaning? if you apply 1 amp here,
Then,
you will get m volts here.
okay.
Let me introduce standard metal inductance of 10 millihenries. Manufactured 1938. Here is a signature 9438. This thing survived war. It's a standard metal inductance of 10 millihenries.
Survive with what?
War. You know what? We got a war. Second World War.
This survives.
No, yeah. Second World War started in 1938 and ended in 1945
Yeah.
with surrender of Japan. This thing manufactured 1 year before the war. It's an English made. Griffin and Tato Limited. Audited, but real manufacturer is a company, was a manufacturer called company called Tinsel. It's a Tinsley and Co. Limited, London SE25, standard self-inductor, also 10 millihenries. It's a also pre-war. No, this 6-digit number, it's a second church. What I would like to say? Yeah, metal inductance. It has a dimension of inductance. It's also measurable in henries, millihenries, and so on. And it will appear as omega. But not as a branch resistance, but as a metal resistance between branches. Now, idea of nodal admittance technique. First, I would say what anything, coil, resistance, capacitance, all of them can be as an impedance or complex resistance. Yeah? Yeah. Now, technique itself. Okay. Ohm law, current in complex is voltage in complex divided by, it's easy. Or multiplied by y, where y is 1 by z. What's the name of the y? Conductance or admittance. Better you conductance. Now, I promised nodal technique. Base idea. We have two laws. Kirchhoff's voltage law and Kirchhoff's current law. Yeah? First one is current. Kirchhoff's current law. Sum of all current in any node equals to 0. For example, I have a node 1, node 2, node 3, I don't know, maybe this is node 4. I have nodes. Resistance. This node, if measured against ground or base, this node will have potential with 1. Yeah? If I measure against ground, this will be potential 2. What will be current? Current from 2 to 1 will be P2 minus P1 and divided by Z12 or P2 minus P1 multiplied by conductance 1, 2. Is it correct? It's Ohm law, yeah? I don't know how. There is something. There should be an energy source. Current between 3 and 1. Current between 3 and 1 should be P3 minus P1 multiplied by 3, 1 and so on. Same with all current. And what we know about all these currents? What sum of all of them equals to 0. Let's say I need one node to be a base node. I need to fix a ground, or there will be no solution. For this current, there will be, for example, I will assume current flows like this. So this will allow me to write P1 multiplied this current 1 to base equals P1 multiplied by conductance 1 to base equals, and all they are 0. If we take a sum of current, we will be able to write something like this. P1 multiplied by, sorry, not that, but conductance 1, 2 plus conductance 1, 3 plus blah 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 conductance 1 base minus Phi2 conductance 1, 2 minus Phi3 conductance 1, 3 minus blah blah blah, but not the base node, because base node potential is 0, equals to 0. If there would be not 0, but if, for example, I attach a current source in some node, this will transform into equals on E, where Y is a nodal admittance matrix. Y11 is a sum of Y1, let's say, from 1 to number of nodes Y1. The main diagonal is so called 2 is a sum number of nodes Y2 and so on. So Y, let's say
I think I'll end up stealing your notes.
I is sum from 1 to number of nodes I where I change from 1 to number of nodes. plus k is one moment. Yeah, and k is one moment. This should include base node. That's why plus 1, plus 1, plus 1. This one is for ground or base node. It's one moment. All so-called all conductance or conductance at the main diagonal of this matrix do include conductance to the base or grounded node. This technique requires one of the nodes to be base or grounded. It's a reference point. So, I need to fix voltage or potential on one of the node. Here potential. That's why I'm writing this plus 1. This plus 1 is for base node. Node where at the first point where potential is 0 or grounded node. Other elements of this matrix so y I including excluding I equals are minus conductance between node I and here I from 1 to number of nodes, not from 1 to number of nodes. This part do not include base node. I'm writing this. Appears, what are you doing? You should conduct this matrix. No, machine will do it for me. I will not conduct this matrix. I will take one step back. 1 second, I need to write an I vector. I is a vector of current sources. I'm not forgetting about M. So I is a vector conducted by node, and if current source inflows in, I write it plus. If current source outflows, I should write it with the minus sign. It's very easy. Another easy thing is a matrix of incidence. I need network topology. And matrix of incidence node, branch. If branch flows into node, I should write minus 1. If branch flows out of node, I'm writing 1. If there is no connection, I'm writing 0. I will use M capital for designation of this matrix. It all in your books, it can be named A or gamma. Other designation for matrix of such structure are A or gamma. This matrix encodes, how to say, network topology. Kirchhoff's current law, M, this is vector of branch current, equals to I. Think what I just wrote. Nodal admittance will look like. Where's the connection? One moment. I will make a connection. Y is M transposed. What is the Z matrix? It's a matrix of resistance. Inverted, it will be matrix of conductance. This one Kirchhoff's current law converts into nodal voltage equation with this knowledge. It's a first Kirchhoff or Kirchhoff current law written through the nodal voltages. For you, nodal voltage are the same with potential. For real power engineering, they are different because in real power engineering we often use line-to-line voltage. But at this moment it's not a problem. Here, Y is an inverted resistance matrix and M transformer. This resistance matrix, for simple case, it has a very simple structure. ZII is a resistance complex of where I from 1 to N of B is a number of branches. At the first, you feel only main diagonal. It's for simple case. 99% of your cases will be simple. So, you just need to fill you just need to fill this part. Element number 1 is resistance of the first branch, element number 2 resistance of the second, and so on. My case is not so simple. I deliberately took a case with inductance. Here, watch closely. Let's say this is branch 2 and this is branch 3. And I have a mutual inductance between them. Here, positive for each branch in topology. You understand it from the definition of the M matrix. I need to select a branch direction. So if you have both branch where branch inflows into winding 1, this will be positive. For this case, Z2 3 equals to Z3 2 and equals to omega n. If you one will flow in opposite direction, both will be negative. And each moment, if your network do not contain any mutual inductance, your resistance matrix will be pure diagonal. If your network contain mutual inductance, magnetic couplings, coupling elements appear in pairs symmetrical to the main diagonal. 2, 3, 3, 2. Km, Mk. One more moment. What should I do with EMF? At this point, I wrote only current source. What about EMF? For in case of linear network, I can assume that each EMF produces its own current. And I can expand this Kirchhoff law with M. Here each EMF produces its own current A divided by resistance. EMF factor A is conducted by branch, and if EMF is co-direct with the branch, I should write it with the plus. If EMF is directed against branch, I'm writing with the minus sign. Yeah, what's now? Now I need to draw my schematic. And we will my rectifier will be substituted with a map. Fourier row elements will appear here. Next one, what I got? Coil 10 millihenries, 6.44 ohms. And 10 millihenry. Coil. Here, next one, this nice capacitor 10 microfarads. What's next? Next, my nice metal inductance coil. It has a self 7.47 ohms. Itself really 6.47 ohms. It has a self-inductance of 9.3 millihenry. Metal 10 millihenries, and I use 240 ohms resistor to limit current. Yeah, on the secondary side, what's on the secondary side? Here I got ground, capacitor 5 microfarads, self 7.6 ohm, 7.6 ohm. Inductance of the secondary part is 253 millihenry, and also I put a resistor in series. This one nice resistor of 10 ohms. Why? Okay, I have 10 ohms here. Here is my schematics. This is ground. What shall I do? Now, I need to select nodes and assign a number. This will be node number 1. This will be node number 3. And this will be 1, 2. This will be number 3. This is reference point based node. Next, I need number to the branch. This will be branch 1. This will be branch 2. I think this one will be 3. This one will be 4. Let's say 5 and okay, maybe 6. here I have numbers on all nodes, numbers and direction of all on branch. It's necessary. It's mandatory. You need to number nodes, select base node, and number of branch and assign directions. Now I can, what can I do? I can conduct an incidence matrix. 1, 2, 3 node. 1, 2, 3. Branch 1, branch 2, branch 3, branch 4, 5, and 6. Let's take a look. What can you tell about branch number 1? Flows from base node into node 1. Minus 1, 0, 0. Branch 2. This one is number 2. Flows from the node 1 into ground. Number 3. From number 1 into number 2. 0. Number 4, from number 2 into ground. Number 5, from the ground to node 3. And number 6, from number 3 into ground. Here is my first incidence matrix, or nodes branch matrix. Need to write minus 1, 1, 1, 3, 0, 0, 0, 0. Next row 0, 0, minus 1, 1, 0, 0. Next one 0, 0, 0. One more 0, minus 1, 0. Something like this. 1 second, I will make it better. This one is nice. Now what I'm doing, I will take a small code. I will reuse small part of my code. Okay, what I'm doing. ZS, it's from Latvian, Zaruskaits. It's number of branches. MS, Mazgruskaits, number of nodes. I size is a measuring operator. I have measured number of columns and number of rows in my matrix. This will give me number of branches, number of nodes. I just don't want to think. Next moment, this one. I need transposed matrix. So I just create a matrix where same as original, but rows are swapped with columns. This is very simple. This part, yeah, here I need an AMF vector, and I do have how many? 6? Number 1, number 2, number 3, number 4, number 5, number 6. It's okay. This one is an AMF vector. I will have only one AMF, and it will be my element of Fourier row. Be careful with this minus sign. Fourier row is basically, everything starts from cosine. Electrotechnics deal with sign. To compensate this, I need to take a minus sign at a sign curves. Next row, GV is nothing else than J omega, imaginary omega, imaginary frequency used by Heaviside and Steinmetz in their technique. 1 second. I need to switch. Yeah, and also so why? It's a chart. Fix it. Graphic window 0. And I have also graphic window number 1. What's wrong? Where am I? What I'm doing? I'm showing this part. Why I'm doing this? Maybe I will comment this out and start from this element of this part of code is a vector, main diagonal of resistance matrix. What I have on the first branch? I have my coil 644. Yeah, my coil here it is. I will copy. It's a resistance of the first branch. What's the second branch? The second branch, I have a capacitor of 10 microfarads. Oh, come here. Here is my capacitor of 10 microfarads. So for resistance, I write resistance. For coil, I write GV is a square root of -1 multiplied by its inductance. If you take a look here, complex omega angular frequency is double P multiplied by frequency. I define it here is my 50 Hertz. Yeah? But one more, K, number of harmonics. I will perform nodal analysis for each AC component, started from the base, number 1, and ending with the 70. Yeah, I start from 70 harmonics. So I will do it 70 times. And frequency of second harmony is double, third triple, fifth quadruple, and so on. That's why I have a harmonic number here. And on each step of this 4 cycle, I will have correct frequency. Understood? If understood, I can put a branch number 3. And my branch number 3, 6 point, I think this one. What I wanted to copy this, not one. I need, this is resistance of the third branch. 6.47 is a resistance of copper wire making the coil. And 9.3 is self-inductance at a base frequency. For second harmonic it will be double, for third triple, for fourth quadruple, and so on. Now I have branch number 4, 200 here. This will be number 4. Here is my branch number 4. What about branch number 5? 7.6. This one, I think it's for branch number 5. And branch number 6 is 10 ohms plus 1 divided by multiplied by 5a minus 6. 5 microfarads. Yeah, 5 microfarads. Here it is. I have my branch resistance. But I also have, what do I have? Magnetic coupling between branch 2, it's 4 and 5. No, 3 and 5. Sorry, 3 and 5. 3, 5. 5, 3. Couplings between, I have one. If I would have more mutual inductance, I will need to put more these pairs. They appear in pair. Now I have one little problem. And my problem, I need an inversion. Because in matrix algebra, we don't have a division operation. We have multiplication by inverse matrix. I need matrix inversion. Can I call a help brigade on matrix inversion? No one here. Should we take a break? Do we have someone on 1-0 view? Okay, we can take a small break. Or we can continue. What will you say? Break or continue?
Break.
Break. Okay. Right back. Common push on envelopes.
Is it break?
Yeah. Jā, lekcija.
Tikai lampiņam sakot,
Nē, mums tieši tagad var pārtraukt.
Alright.
You stay here?
Yeah, I'll stay here.
Okay.
Pārtraukt.
tādu lampiņu nevajag. Es tur ledīju skrūvēju, pēc tam un tādu.
To lielu? Lēti.
500 patīgā nevajag šitā.
Kādi? Galotien?
Jā.
Cik mums tā liela? Izrādīs tur pildījums, neonis. Tā sarkana. Jā, tu ieslēdz priekš panumu. Neons.
Professor,
Yeah.
can I use this charge my laptop?
Yeah, there should be a voltage.
Alright.
Negribas tādu konkrētu.
Nevajag.
Vai gaišāk?
Taupīt vajag.
Taupi.
Tas, ka bija lielais savs, varbūt vajadzēja atstāt iesākt.
Votu,
Vai sildi.
nu, daudz neuzsildīs, bet
Sildi bija nesamūžs.
Kur tā maza ksenona?
Es atceros veselu kastes ienu ārā. Es viņu vienu izvilku.
Lūīt ieslēgsies. Tā taču ir pieejama.
Tikai, nē, tā pa maziņā.
Nu, ot, tā ksenona tā ir. Ksenona no kastes kur viena.
Tā lielā.
Tā liela. Nu, tur iekšā neons un tāds smūgs sākans tā. Nu, bija 500 vati nomināli. Bet pildīja, es domāju, pildījums ksenons kriptons. Aizrādījis neons kriptons. Nē, neons argons. Un tad sakana, 500 vati sakana. Tā balast kā dienas gaismas, nu tikai 500 vati. Nu, es no poštām izlūku. Pildēju, smūgs sākās. Vajag samontēt skēmi.
Un šitā, ko es atceros, man tur vēl kapjos vēl šitā daudz neizjaukt.
Tu darīsi, viss izsaka.
Nē, cik jau tur bez metris, tur tukš, neviens nav tur. Nu, tāpēc, ka es tur visu laiku grozos, neviens arī neķerēs viņam klāt. Tur bija, nu, 4 tur bija, šitas jau specisku iegunuši tie automāti. Tur ir 04, tur es pats esmu izpildījis. Un arī ieraudzīju, tur institūta direktors, tā, dod man atpakaļ, dod, tas ir institūta īpašums, mēs paši nodrošinām. Un tur kā nomaitāja, tas tur mums ir izpildījis. Nē, nu tur tie maziņi bija. 100 ampērīgi.
Šitais arī nav milzis, 170. Visu laiku. Man galva ideja, man mīl tas 3-fāzes pildījums demonstrācija. Un vai parādīt, kā. Kā smuks strāp. Va? 2 fāzes, 1 pilds. Man kaut kā galva tādu ar selēņu pildījums attaisīt, lai būtu tiem cita rakstura, tiem lielāk iekšēji pretstīgi. Un savādāk izskatīsies primāru pusi. Šo vēl māc daudz ko. To, kas notiek krāpuma primāru pusi, tur tāda interesanta dubulta kalna. Man kaut kā ideja paņemt, man ir viens maziņš transformators, vēl gribu, ka laboratorija radīja šādu. es pielaidu tādu mazu trafiņu, un to ar selēnu.
Tie, kas, ko mēs ķīmikos skatījāmies, tie modelē,
Tie bija, nu, tur jau kā, es domāju, ko tu metēs, ko es savu, es jau nolikavu savāku. Nu, tie ir tas ripstu. Vai estetiski būtu, nu, vienkārši uzskatāmības pēc. Tu uz grīdas metēs. Saskatāt, es domāju, ka tur no trim vienu var salikt, vai krūces. Un tāda atmosfēra. Ne, varbūt te, ot, 38. gads. Koka transformātors, par kuru visi dzirdējuši, bet maz par šeit. Tā ir etalona induktivitāte, 10 millimetri. Causais, ja. Koks eldi, uztīt. Ot tāds pola arī. Viss sapam koks. Inski. Konģuks. Priekš laboratoriem. Un pēkšņi.
Es šitas garā augsts. Braudņš. Viņš jau arī vēlojas. Nu, arī viss vecās iekārtas ir. Cilvēks apmakstīja, un tad ieliek, izliek. Mēs skādiem. To kā elektroniskie, nu, ieliek kaut kādu aktīvītu
Jā, nē,
izsekot. Viņiem to nevar paskaidrot.
Vēl raudēju. Veciem čugunu motoriem absolūti sanāk ideāli kā raksturāni. Ja mēs to optimizēt, tur mums optimizēt stāvā, mēs nesanāk raksturīt. Nē, nu kā tēma optimizēt.
Ir ļoti, to joprojām motori. Ventilācijas sistēmas, viņam stāv.
Facebook runātājs. Cilvēki vēl pirms kādu motors remontē. Vēl stāpīgi, līdz turpinātāji, kur lielu naudas nedēļu jaunas motors. Nu, no citas puses parāda. Viena lieta parādīja kaut kādu reģistrālu, ot tādu. Es taču īsti ar selēnu. Ko ir 100 gadu? Un tā ir. To taisīšu. Nu. Visā rūk. Ko tādas demo kondensātori. Kīvot kādas pirmīgiem. Nu, var ņemt parasti kondensātori. Jā, Iekstārtīgi. Etalons pols, es modelis neliecēju. Tā. Tagad var dabūt to, ko vācieši pārdod. Ķīniešu sūdi un nec, nu, pēc principu, kas mums ir, to arī piedalās. Aha, priekš vienfāzi.
Nē, tas trīs fāzi. Uz motoru atsīsim 15 un 4. Ieras 14 bandai automāti. Gads. Biežā.
Vispār oriģināli, mēs jau nevaram 300.
Tā nav pirmā. Tā jau ir otrā iekārta, kas mums limitiem bija tas pats. Viņam arī granulu apcinātājs dzirnavs.
3 stūris uz 380. Uz 200.
Nē, 380, jā, 3 stūris.
Vai 320? Nē.
Tur skatījos, tur bija, tur tas apzīmējums, kurā vietā 3 stūris un kurā zvaigzne. Jā. Tas ir pirmais. Jo tad varbūt viņš ir 600 kaut un līdz motors.
Varētu, protams, būt. Vai viņš? Un ot tā raksta 300. Bet tur visi 6 sāri?
Nē, tur ir gatava iekārta.
Nē, motoram. Viss saslēgts uz...
Tur jau paši vadības panels ir. Un no vadības paneļa aiziet uz motoru.
Tur viss saslēgts. Nu, cilvēki ir dažādas idejas. Man tā uzreiz, es redzu 3 stūri, man pirms doma ka...
Vai? Kā ieraudzīt, domāju, viss. Tur vecais trapiņš jāsazāk. Es tur sāku pētīt. Pirmās 3 stūris, pēc tam zvaigznes atzīmējums.
Nu, varētu būt kaut ko mums zvaigznes.
Zvaigznes, kas sanāk, varētu būt tur 7.
Viens variants. Otrais variants, viņi raksta saudarbību, un tomēr tas ir 380. Un ar to invertoru nav? Kādas tāda ikipāna interesanti. Ir invertori. Viņi domā 220, bet no 220 nesanāk normāli. Un viņiem ir starp posms, kur viņi cel spriegumu līdz 600 voltiem. Un invertoram tā aktīva daļa, 6 IGBT tranzistori, lai būtu mazāk strāva, viņi strāva no 600 voltiem. Viņam pa vidu step-up konvertors. Ir tādas ikebānas.
Tad es atceros, ka nezinu, vai es teicu, ka viena nolīdīšana
Vidiniekam tas mazliet netev.
Jā. Un kas tad ir? Uz slēdžu. Uz vienu aiziejušo vēl bija pielikt fāzi, uz otru noli. Tā kas vajadz ārā. Vienā fāzi aiziet uz nulles labi. Droši vien pirmo reizi, kad ieslēdza, nosilināja to kontaktu, ka viņš pēc tam vairs neslēdza. Bet it pēc kaut kādu laiku tas kontakts kaut kā parādījās.
Ir dzīvēs tāds.
Es viņu prasīju, cik sen tas slēdz. Viņa teica, tas slēdz ir
no sākuma. Jānobūs. Visādi ir kāds cilvēks.
Mums bija vienkārši vienās aiziet, vienās parādās. Fāzes caur slēdzi. Acīm redzot schēmā viņiem bija tā, viņiem jābūt dubulu slēdzim bija. Gan nulli un fāzi jāpārās.
Viens variants. To vajadzētu paskatīt, kas ir Fourier. Un montējs tāds dušīgs no aizvēksties. Varbūt sajaukts kaut ko. Vai domājas, ka tā ir starpsavienojumi?
Nē, ir slēdži.
Ir slēdži
Kur atsevišķi tas X, Y kontakti.
Vai tu sajaukts?
Mums ir vairāk, jo pirmā reize pagādīt.
Nu jā, viņi saprieši, kas sīt automāti.
Jā. Mēs domājam, laikam motors. Mums vairāk tie, kas kondicionēja montējas, iebojāja vadu. Nu, arī vakar es paņēmu, kas slēdz ieslēdz, un tas vienīgi. Pēc viņus atnāk, nē. Viņš pasaka, ka viņš kaut 15 minūtes atpakaļ, vienkārši tas pats ieslēdzās. Stiprāk piespiediens blīšas notiek.
Siltumnīca.
Es arī pirmo reizi siltumnīcā redzēju, kur lūks audzēja.
Modelis bijis kā regulātors, termoventilators, un ja pāri atveras lūks. Pasaules kaut ko, citāk viņas jauki uzēja.
Kopā studijām, tagad ir liela projekts, kas ir fiksēt,
Kaut kur var izmantot. Kaut kādu dēmu. Vienīgais, kā temperatūra. Ir variants, ka taisa regulātori. Un smuk zīmē, ka paņem tagad uz datoru, lai būtu redzam, kā aug temperatūra un kā krīt. Tur ir eksponents. Tas pamato pīštie pakapiena regulātori. Laiku pakāpi augoši. Jo tā, ja man vajadzētu turēt temperatūru, tad sanāk, ka process eksponenciāls. Viņas izmanto tikai uzsiltācijas, uzsiltācijas. Nē,
tās lampas jau viņas jau reiz gadā utilizācijas, tas kā minimums gadus. Bija mums ļoti.
Lampa ir lampa. Eiropa konteksts. Bija vienīgi mazu akurāt tīkliem zem komutācijas spēja. Pat ne kontaktoru nepavilks. Tur vēl stāt oriģināls elektrons relēs. Bijuši varianti, kad tie FKM tīpa relēs jutīgas un jau tie vada kontaktu. Tā pārējais tie elektrons relēs. Diezgan maz komutācijas spēja. Stāvēšu uz ķīmijas procesiem un siltumnīcas. Un uz visas sienas balts.
Tā ir vecā māja, tur sienas biezas.
Bet sēniši
Tepiņā tur bija viss balts. Un sniegs no grieztiem.
Normāli.
Viņa, kad ieslēdz, kad ir sasniedz temperatūru, viņš kaut kad 25%. Tāpat turpins vēl.
Turpin. Nav tur tā liela starpība. Tas termisko efekts nav.
Ūdens cauri, un tas jau bija 45 grādi. Laime būs.
Bez otras.
Apēni mazu. citā mājā arī. Sanāk? Neviens netērē ūdeni arī. Otrajā stāvā. Karsto ūdeni un tur karsto.
Nu, padaut uzvaru. Vajadzēja lielāku soļu. Nu, tas ir. Ko? Es nepatīk. Man atvērts. Viens interesants objekts. Līdzstrāvas skaitītājs. Nožas. Elektrofīzis. Būs strāva un notiek elektrozi un elektros pārnēs dzīvesūdā. Faktiski uzskaita amperstundas. Ukas. Tur tā ir pusē dzīvesūdā un ar elektrozi pārnēs dzīvesūdā. Tā stāv vertikāli, pēc inspektors atnāk, noraksta cik bija un hop, atgriež dzīvesūdā vārtā. Vācietis. Stija Zahra. Vai amati tur trūkst? Nu, tur cik tur ir uz mēnesi koku? Nu, 5 amperi, nu, 380 kWh. Man, tur bija vesela kolekcija. Nu, viņi gaidam demonstrēt, tur bija šeit 50 amperi. Ar tad kārtīgu šunu. Nu, šīs vācietis, vāciešam arī bija līdzstrāvas. Sveicēni ir vilces līga. Uzsver. Vilcēni. Jo rokumēļi. Kolektoru motori. Nekā fiksot. Jā, jāarbā. Jāstāst. Lopsoļs. Okay, I need back. And in my back I have next problem. Can we continue?
Yes, we can.
Yes.
My subject, 2 kilowatt. Very nice 2 kilowatt length. It is 300. Here. We need to go we need to go forward. And what's next? Problem, I need matrix inversion. Because I don't have division. I can do it with the help of Jordan's technique. For electric calculus, I need an inversion of branch resistance matrix. How can I do it? I can apply Jordan's technique. Actually, since if A is a square matrix and it can be multiplied by its inverse, I should get a unity matrix. Yeah?
Yeah.
Yeah. If I apply Jordan's technique to this, it will transform it to the form unity A inverse equals to some kind, I don't know, B. So, what's the Jordan's technique? If you have a matrix A, size n by n, it should be squared, should be positively defined. Recalculate. Do it. Assume that A is an A0. From A0, calculate A1. So on from A k minus 1, calculate AK. Here k should change from 1 to the n, to the size of matrix. At the end, you will have an, and it will be desired inverse matrix. You need to recalculate matrix n times. And each step, do it like this. K. Next should be 1 against K previous. IK next should be AIK previous divided by AKK previous. Here I should change from 1 to n and exclude element number k. AKJ next should be minus AKJ previous divided by AKK previous. KJ should be changed from 1 to n and exclude element number k. 3 formulas. One more. One more. AEJ. Next should be AEJ. Previous minus IK AKJ. Previous divided by AKK. Previous. For each I starting from 1 and ending to the number of element, for each starting from 1 and ending to the number of elements, and you should exclude element number k. Come here. Where are you? Here is a small function. Jordan is a name. I need to put it somewhere here. It will return me an inverse of the here. This row calls its function to get inverse of the resistance matrix. Next, this is for nodal admittance technique. This is B side. So I will need to solve an equation system. System of the equation. Sorry. Minus this one in my case is 0, but M transpose with this system is 1. It's a nodal admittance equation system, or equation system of nodal admittance technique. I will need to solve it for frequencies starting from 1 omega, double omega, blah, blah, k omega, ending with n half omega. Actually, I will need to solve it 70 times for each of the harmonics. How will I solve an equation system? I will use a technique of secant approximation or Seidel technique. Who ever heard about Seidel technique? Ludwig von Seidel developed it. No one. What your Google friend tell you about Seidel? Ludwig von Seidel only mentioned in his technique to solve linear equation system. If you have system Ax to B, possible if some conditions are met, convergence conditions are met, you can solve it in the way x0, x1, blah, 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 it's something, and each of them will be closer to real solution. In a way, next x number I is sum from 1 to I minus 1 ci dot x dot. Next, it's next from the previous, plus sum m change from I plus 1 to number of equation cim xm previous plus di, here I changes from 1 to number of equation, and this c is calculated in way what ci dot is minus ai dot divided by ai from the original A matrix for each from 1 to number of equation, and each from 1 to number of equation. D I is B I is divided by AII. It's a very simple solution, way of sequential approximation, or way of iterative precision system. I hope met this condition. So you see, I'm writing here Seidel. I will copy my Seidel. Where is my Seidel? Function Jordan. Oh, here it is. My Seidel. You can see sum number 1, sum number 2. It's what you see on my blackboard. I will put my Seidel function. Okay, I can put it in front of my Jordan function. Both are mine. Seidel function. Where it is? Here I call Seidel function, but Seidel technique allows me, where it is? Here I define precision. I can solve equation with any precision I need. With tiny moment. Nature of precision of this computer is 16 digits after the comma. So if I put 0 there, I will get minus 15. Okay, but it's not. Here I have small problem. I have we can try to maybe absolute values of like this. Yeah, here is the Ohm's law to get branch current. The result, these things brings out branch current. Let's see, at this moment it should produce 70 hey, come on, will you produce, where's my console? Inconsistent row column dimension. Inline tiny problem 190. Where is my mistake? Inconsistent row real. Oh, work. Yeah. Here I have voltages, nodal voltages for all 70 harmonics. I have full bridge, so I can predict number 7. Should be 0, number 6, yeah, here they are. Here are my Fourier solution elements. Fine. I don't know, left it or... Okay, maybe I will switch this. One problem. What kind of problem do I have? I need to solve DC regime. And for DC regime, I should exclude all capacitors and short circuit all coils. I will do one thing what should be committed as a crime. I will calculate DC regime as a very slow AC regime. I will use this as a template, but I will need to do, I will copy this. Don't show it to your electrotechnics theory teacher. I calculate DC regime as a very, very slow AC. I'm lazy. I don't want to create a second set of matrices. DC regime should have its own M and Z matrix. And of course it has its own E vector because it's C0. See? C0. One moment. I should point it. Here you see C0, not C0 by half. Here CK minus SK, not divided by square root of 2. This calculus is performed in instant value, in max values, not in effective. Because I need these voltages are instant. Not for instant values. I do it because I need effectors for instant values. Here, actually, I should use a square. If I would like to see voltages as voltmeters show on particular frequency, I will need to add square root of 2. Okay, what's next? Next, at this moment, I have matrix of voltages with such structure. Row number is number of node, column number is a number of harmonic, plus I have 70 rows, row 71 is a DC regime. Now it's time to get time. Here is my synthesis and currents. I will perform a synthesis. How can I get real voltages? DC regime plus 70 values where I got, as a result of solution, I got complex values. Real part is a cosine factor. Imaginary part is a sine factor for Fourier row. Here, T line of synthesis. I got solution as a factor of coefficients of Fourier row. Perform synthesis and you will get what? Time functions. Let's go. And something goes wrong. Something definitely goes wrong because this one okay, this one okay. Why I'm not getting voltages? Because currents. Mistake. No mistakes. 1, 2, 3 should be free voltage. Something going. P1 SP. What's going on? Where is my mistake? Not a number. Here. And voltages. Voltages are fine. Why I'm getting not a number? One, there will be no current. Voltages starting. Oops. And this is wrong. Yeah, this is not good. Not a number, not a number, not a number. I don't like not a number. I made mistake somewhere. Not a number, it's not good. Not a number. Oh, yeah. Wait one moment. Here's my mistake. Of course I will get not a number if I have an unconnected still unlock. Not a number. Hmm. 12, 18. Oh, it's not good. That nice not a number. Just for phone. That's not funny, but okay. Strange. Okay, watch what I got here. Can you see this beauty? Oh, I got something fine. You see what I got? Nodal voltages. Can we check it? node number 1 from 19.5 till 23.5. Can I attach a scope to node 1? Maybe I'll switch to AC mode. Huh? Huh? One moment, I'll switch to AC mode. How it's changed? From 264 to minus 184. Value. U1. This one is similar to U1. Hmm? Something near. Node number 2. Where was node number 2? Node number 2. I think it's wait. Number 2 was this one. And number 3 ground. Case number 3. You know, for experiment, I will disconnect one phase. Let's take a look. What if I disconnect one phase? Oops. Current, wait 1 second, start from voltage. Here how it looks like if I disconnect one phase. Node node 1. You see, can you see scope? O1, this is real. Something familiar? Huh? What will we say? Are this one and yellow line? I think there's node 2. Where is node 2? Wait 1 second. Should be here. Here is node 2. What will you say? Yeah. And node 3. This one is ground. Wait, come on. Node 3. Here it is, my node 3. What will you say? One moment. Here is voltage number 3. In theory, you see? And I need second PV. And here is in reality. Same. Peak and decaying oscillation. You see? Reality. Theory. What about current? Here are my currents. First, for example, you see the second branch current. Huh? One moment. I have this very nice device. It's a 1 ohm resistor. I will put it in the second branch. U, branch number 2. Само много по-силно. tiny problem. Okay, one moment. It's the same, but one moment, I need to check for error. Oh no. It was mistake. I needed to put your figures. It was my mistake. Voltages. Yeah, here is my current from second branch. Sorry, I made a mistake. This one is correct. I had mines at imaginary path. I had to put mines imaginary path. Where are you? Come here. Sorry, wrong one. One moment. Blue line is a current number 2. See blue line? Now, here is calculated. Yellow line is a voltage from the third node, this one. Blue, wait 1 second, I need to do something. Oh. Currents. On one, people now can see currents. So blue line is current number 4. And one moment, I'll get voltages. Here you can see voltage. Yellow line is a voltage number. Hey, come on, I wanted to explain voltage. It's a voltage number 3. I think they are very similar. Here, yellow line on the scale, this voltage. Change the scale. Something similar. You see decaying oscillations? This yellow line corresponds to this voltage. And blue line corresponds to this current. What can you tell about my calculus? It works? Yeah. Fun. Why it's what about power? Something wrong with voltage number 3 power.
I'm trying to watch downtime.
Strange. Oh, can you please stand still? Change power. It's definitely wrong. If I compress time square. And
I'm trying to make a mistake. Strange. I'm looking where
so looks cool. What?
the first one and the second one.
Complete chaos. Dun, dun, dun. Copy. Looks like I first this double should go up. I have a bad feeling that I have a wrong polarity. After the small double, here first one goes down and here up. And then down. Yeah. Sorry. It's because of polarity. Hop, 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 hop. Yeah. Now correct. Now correct. Sorry. I make a mistake in polarity. Now this voltage corresponds really to yellow line. I had it mirrored. It's because of from polarity. Sorry. Okay. What shall I do? Do someone have any question? Any questions? Nice current. Here is technique to solve problem of complex current network. Only, it's very easy, really easy. Only it works for periodic signals. You need a periodic voltage. And for linear network. Compare it once more. It is easy, easy, easy. It's not making any mistakes. I hope boom, 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 boom. How can I do it? Op. Come on. What was the name? Okay, my tiny victims. Nice job. Can you dance? Hey, chop. Yeah, it talks with me. Okay, I can stop stream.